Well, thank you all to our North Houston Space Society October meeting. Um, so the plan for this meeting is I got a couple of opening remarks. Then we'll have Bren Lee do her second space communicator speech. I think you all will really learn a lot from that. I was looking through the presentation, looks fantastic. And then Greg also has the recent space news, and likewise, it's just amazing how much has happened since the last meeting. And it's really a good overview of some of the key things. And then we'll go into having Richard share about GPS and how it came to be. And he wrote a book on it, actually called GPS Declassified. I have a copy of the book. It's a fantastic book. Really goes into a lot of the details in terms of um, kind of the evolution and the thinking about timing and navigation, and then kind of like the series of events that led up to such a phenomenal resource for us to be able to find out where we are and then use that to figure out where we're going. So it's definitely something we use every day. It's good to know a little bit about it. And then we'll have some time for Q&A. And at the end, we'll have some time to share some personal space experiences, as well as if you know of other meetings or other events to call attention to, that'd be a good time to share that as well. So why space? Well, I think largely to improve life on Earth. You got the weather prediction, the Earth observation, TV and radio, communication, and GPS, which we're talking about today. But sun weather also has a big impact on the Earth. There is an event um, uh, called the Carrington event, when there was a solar flare that actually caused fires from telegraph machines about 100 years ago. And if an event like that happened today, it would be very detrimental to Earth. And being able to observe the sun and predict such events and take protective action is key. And then also likewise, asteroids are constantly hitting the Earth, and some of them are big. And we got to know about that too. But in addition to that, we have some other ways that space could help improve life on Earth. Space-based solar power. We're constantly talking about how we don't have enough energy on Earth, and energy issues. But only 1/700th billionth of the sun's energy actually falls on the Earth. And we could create vast solar arrays that are in orbits around the Earth, at various other places that could actually help to capture more of that energy and turn into something useful for us to actually make society better. And then, of course, getting raw materials such as some rare earth metals, which are actually from asteroids. Perhaps the moon and asteroids would be a good source for those. And then the actual understanding of the universe and our place in it, I think, is always kind of helps us to make better decisions and to kind of see those challenges. And then, as we try to live in other places, we're having to kind of overcome challenges in new ways, which leads to new insights. And then the last one, we may not all be able to go to the frontier or colonize space or be an astronaut, but just knowing that some of us are, I think in some ways provides inspiration to our lives. And, it's kind of a neat thing. So, the vision of National Space Society, of course, is people living and working and thriving communities beyond the Earth, and then making use of the vast resources of space for the dramatic betterment of humanity. And this is a vision that really speaks to me personally, and I hope it does to you too. And if you do share this vision, then I definitely recommend, signing up for our email list, which you could do on our website, northhoustonspace.org. And then also you could join the National Space Society to help support an organization that's working to promote that vision. And I just want to let you know this meeting is being recorded, and we'll put it on YouTube and northhoustonspace.org and Facebook. And if you want to turn on or off your video, at the bottom left-hand side, there's a start and stop video button. And with that, I want to to tell you about the Space Communicator Program. Um, the Space Communicator Program is basically a way to try to encourage our members to actually talk about space. And the idea is that you would give 3 short speeches. One speech would be your personal space speech, why you like space, kind of relay a personal experience. A second one, and they can be done in any order, is like a technical space speech where you explain a science concept or engineering system. And you'll hear one of those today. And the other speech is a community space speech where it's, talking about us doing space, like either history or government, business, education, something like that. And the real goal behind all this is just to kind of give you a platform to try out communicating. And with that, let me turn it over to Bryn Lee, who's going to give us her um, second speech. So Bryn Lee, I'll pass it to you.
Hello. Okay. Hello, my name is Brinley Wright. I am 10 years old and I want to become an astronaut. My presentation today is on the Artemis spacesuit. The Artemis mission will send the next man and the first woman to the moon in 2024. I want to thank Miss Amy Ross, NASA's spacesuit designer, who designed the Artemis spacesuits. We interviewed her last week about the suit, so much of this information will come from that interview and NASA and internet resources. Over the decades, people have designed spacesuits to protect our astronauts. The Artemis suit is no different. The purpose of the suit is to keep astronauts safe during long spacewalks and to protect particularly from dust, to be a lighter and better suit as well as a prototype for Mars mission suits. However, the most important purpose of the suit is to increase mobility. The most challenging part of designing the suit is to make it lighter. A few things I find interesting about this suit is the communication system. Instead of a headset, the microphones are in the upper torso. Also, the gloves make it easier to use your fingers. The suit is also interchangeable, meaning parts can be changed or adjusted for different environments. So the same suit can be used for the moon or Mars or the ISS. There are 7 to 9 different materials in the Artemis spacesuit. Some of the most important are Nomax, which is found in firefighter uniforms, or Teflon, on the outer layer, which is hard to tear because it is slippery. There are also patch pattern of Kevlar, which is the bulletproof vests are made of. This keeps suits from ripping. There is a multi-layer insulation made of mylar, which is the material in balloons or spiral blankets. Under the suit is a thermal comfort undergarment and a liquid cooling ventilation garment to help cool down astronauts and lightly helps protect from radiation. Cold water flows to the garment through tubes and into the portable life support system and cools down again. This undergarment also holds the diaper. So what is the difference between the Apollo spacesuits and the Artemis spacesuits? Number 1, the Apollo astronaut suits are custom made by creating a papier-mâché mold of each astronaut. The Artemis suits come in sizes medium large, where the shoulders and torso can be adjusted to fit various sizes. Number 2, it is created for long spacewalks that can last up to 8 hours. And most important difference is mobility. The bearings are part of the suit, similar to wheels that can help you rotate or move your body. The Apollo suit had bearings on the wrist and shoulder. The Artemis suit had bearings on the wrists, shoulders, as well as the waist, knees, ankles, upper arms, and making it much more mobile. No more bunny hops on the moon. Fun facts. Designers are still working on it, on the spacesuit, and it is adjustable to fit most people 5'4" to 6'3", and each costs as much as a car. But most importantly to me is I can dance in it. Thank you for listening to my presentation on the Artemis spacesuit. My name is Brinley Wright, and my goal is to dance on the moon.
That is really awesome, Brinley. I want to give you, well, I guess I got to turn off my background so you can see it. Hold on a second. Choose virtual background, none. Okay, cool. I want to give you this a certificate for completing your second speech, but that was really fantastic. Well, does anybody have any? There we are. It's amazing. It made it all the way over there so quickly. So did anybody have any questions for Bryn Lee about spacesuits? Well, I had a question, Bryn Lee. Let's see. When is the first time they plan to actually put the spacesuit? I mean, will they test the spacesuits on the ISS, or will the first time that they actually test these spacesuits be on the moon?
She didn't say that they will test them on the ISS. Miss Amy Ross, she didn't say that they will test them on the ISS. I think it's just going to be on the moon.
Awesome. And any other like really interesting tidbits that you learned from your interview that didn't make it into the presentation?
Let me think.
We do have a few things. We've interviewed a few people, actually. We interviewed 2 astronauts last week and a SpaceX intern.
Mm-hmm.
I think one of the most interesting things we learned about the suit was how it can be used in different environments, like how you change it, how it's interchangeable. So we asked our friend Barry Wilmore, who's an astronaut, what he thought was the most challenging thing about going to Mars, and what did he say?
He said extra parts.
He said spare parts.
Yeah.
And Amy kind of agreed with that. When we asked her what she thought would be the most challenging part about going to Mars, she said yes, because something on your suit is going to break. And she was saying that the moonwalks are longer, so they would be about 8 hours a day, and then doing it every other day for about 500 days, right? For about 500 days. So she's like, inevitably something is going to break, but they're working really hard to try to make the suit as durable as possible. So the goal is to try to make the suit last 250 days while outside of a spacecraft. But I just found it interesting that was the answer.
So did they say anything about dust and how to mitigate any dust effects on the new suit?
They did say that the gloves will wear out really fast because of all the dust. So they're trying to figure out how to get more gloves.
So that's one of the challenges of the design, is to make it particularly strong or defensive against dust particles. So that's like a particular thing that they're trying to work into the spacesuit.
So did they change the materials from the Apollo suit? The materials of the Apollo suit was very strongly attracting the dust.
Yeah. Yes. They did change the materials, but I don't remember which exact materials were specifically to prevent dust particles, but I know that was a change.
I think that's going to be one of the big deals with it. Thanks.
Yeah, and it's still a work in progress. And when we asked, like, so her designers are still working on it, and they're still tweaking it. And because when we said, well, how much does the suit cost? And she said, a lot. and she's like, we really don't know. I know NASA doesn't like revealing how much their things cost. But she was like, we really don't know, because we're actually not finished with it. So they're still testing and still trying to improve on the weight and on the protection of it.
Yeah, they're still trying to make it lighter. Still trying to do that.
I did see a article this morning about, there's a company in Austin, a 3D printing company, and they're actually trying to figure out that they want to use that on the moon so that they can 3D print buildings on the moon. So maybe that's the answer, getting a spare or getting parts 3D printed while you're on the moon.
Yeah, that's what Barry Wilmore said, that the 3D printer technology that's improving, and it's just finding materials that they can send that's like light enough, right? Because we don't want to add weight to the spacecraft, and then but still heavy and durable enough to be useful. So that's a chance. But yeah, 3D printing is definitely what they're looking at and the way they want to go.
Yeah, hopefully being able to use the materials that they find there to be the bulk of the 3D printing stock.
Yes. Yes.
So are these meant to be modular, like you can just pop out a part and replace it, or is it going to be a major repair to replace a glove?
To replace a glove? You know what, so remember she did mention, because we talked about that a little bit, about having enough gloves. So I know the suits are adaptable, but I think if there's something like the glove or something on the glove that breaks, it would actually have to be replaced. I know that particular, because we were joking about how we're going to get enough gloves to Mars. And we're like, well, maybe we'll send some with the rover and they'll just be there whenever we can go, or something like, we'll just have a stockpile of gloves already on Mars before we get there. So I know the gloves particularly was something that they were concerned about breaking. But as far as repairing things like that, I mean, I know, what was it, the Kavlar, one of the cross stitch pattern that they have, they're just really trying to make these well so that they just won't break. I mean, that's the ultimate goal of what they're working on.
Well, we know from the Apollo suits that probably 1, maybe 2 more EVAs on those suits and they would have been failing, would have been leaking and stuff.
Yeah, so these are the last one.
I have a question for Brendan.
Again, because of the dust. Go ahead.
Do you want to be just an astronaut in general and see as much as possible, or is there something specific about the moon that's your goal?
Just being astronaut, either like a ballerina astronaut. Yeah.
The first professional dancer in 0G.
I'm going to in May, so I'm really excited just to feel the astronaut ways.
Actually, Victor and Brindley, y'all just touched on something that I wanted to mention. Last month, we had a guest speaker, Marubal Jha. He's from the University of Texas in Austin, and he studies astrodynamics, but he's really active in a whole bunch of space activities. And I found out, or at least it was announced since last time, that he's going to be part of this reality TV show called Space Hero, which is a contest, a global contest to select an individual to go to the International Space Station for 10 days. And the same company that's going to be sending, there's a company called Axiom Aerospace who is going to be managing logistics, and they're a real company. So I think it's a pretty legit operation, if not fully funded quite yet. But definitely worth checking out. It's called Space Hero, and their website spacehero.me. So it might be kind of fun. Well, I guess with that, Greg, you want to go ahead and do the space news?
Sure. Give me a second here. All right, let's see. This is still your screen up here. Oh, there we go. Okay, well, space news, October 3rd, that's the covering since the previous meeting. And it's mostly going to be on 2 topics, the moon and also a surprise new entrant is Venus. Nobody's really talked much about Venus lately. But first we'll talk about the moon. And this is really driven by NASA in this case because they've released some new plans covering mostly things we knew about, but they put more numbers on them and they package it all up quite nicely. This is actually a picture from their brochure, which is one of the possible landers on the moon. And that's one of 3 which will have to be selected. So their main program is the Artemis program, and we've mentioned it in passing before. may not be obvious where the name came from. Artemis was a twin sister of Apollo, so it's really quite appropriate. Also because she was the goddess of the moon, so it's a very appropriate title. The short-term goal is to return astronauts to the moon in 2024. Longer term, the real emphasis is really a permanent presence. You know, we're going back to stay, which would include a lot of other things, such as utilizing resources that are there. You know, in the distant future, we certainly hope that we're making rocket fuel and that sort of thing. One thing they're really emphasizing now is a moon to Mars approach, and actually that shows up in all their the pictures that they put on their documents. So, for instance, here you'll see the moon, and then there's Mars kind of suggestively. But I don't think you'd actually probably see that view anywhere. But the point is that, you know, Mars is really a long way to go and kind of hard to do. So it really makes a lot more sense to go to the moon first, get more practice with supporting people remotely on long missions, and yet in a place where you can much more easily send help if needed. So anyway, this is made up their logo, and they're tying this to a general theme of humanity's return to the moon. Another one of these pictures suggesting the moon and Mars here. So anyway, the new Artemis plan, they've released it. It's a 5-year, $28 billion project. And I think the key to this document was, in fact, that they put a more price tag on it. And this is really just phase one, where phase one ends once we actually get astronauts to the moon, with the initial target being 2024. And it has 3 major components: the Space Launch System, which is the SLS, and that's the rocket that gets you there. There's the Orion space capsule, which is where the astronauts would be. And then there's the human landing system. And that is what gets you from orbit around the moon down to the surface. And this is handled a little bit differently. The first 2 are done using traditional procurement policies for the government. They own the SLS and the Orion. This HLS is really being done as a service. So they're contracting it out, and it's narrowed down to 3 teams right now. You know, one led by Blue Origin, one by Dynetics, and also one from SpaceX. And so they're building it, you know, partly with mostly with their own money, with a lot of help from NASA, but they're doing it with their own money as an investment, and as a result, they're pulling in, you know, more private money into the program. Now, the longer term, phase 2 and beyond, that's what accounts for the presence, the permanent presence on the moon, having a base camp in particular, which has long been envisioned to be at the lunar South Pole. Also, there's the Gateway, which has been one of those projects that's had a lot of controversy about it. And because of that controversy and maybe timing constraints, they did not make the Gateway a part of phase 1. That's really part of phase 2. Although they are saying that they're still going to be launching some of the Gateway modules in 2023. We've talked about the Gateway before. The Gateway is basically a small space station that would be orbiting the moon. And it would be used as an intermediate point, a transfer point for astronauts, or even for cargo coming or going in the future. Now, one thing NASA did warn about is the timing to really do this in 2024. They really do need to get the funding for the human landing system in particular this year, and that hasn't happened yet. So they're expressing concern and saying, hey, you know, if you really don't put up the money, we can't do this. They are hedging a little bit on the landing sites. Long term, they've always said that the base camp, you know, the future landing sites, and even the initial landing site would be very close to the south pole of the moon. That's quite strategic because there's water there, there's sunlight available most of the time. The water is crucial, one, for being able to live off the land in the future and doing things like creating rocket fuel. But now they're saying, well, maybe they won't go there first. They still will go there, but maybe not first. I almost think that was more of a trial balloon. The reaction to that was pretty negative, so maybe they'll go back to doing it. So phase 1, a little bit more details on that. There's 3 launches, Artemis 1, 2, and 3. So the first one is basically just involving the rocket, the SLS, and the Orion 1 capsule without anybody in it. They do a 1-month test, they send it up, it goes around the Earth a few times, goes around the moon, eventually comes back, but no astronauts are involved. But this tests out everything. It tests out the rocket, you know, tests out the capsule. And in particular, it tests out the re-entry. You can't really kind of fake that with just computer simulations on the Earth. You've really got to make sure that it'll, the heat shield will stand up. And it's a new heat shield. They're still redesigning it apparently. Now there are some side things that get done, just like every other commercial launch these days. Besides the main launch, they're also throwing up a bunch of small satellites. They're in the format called CubeSats, where you've heard about them before. They're typically about 4-inch cubes, or they're in units of 4-inch cubes. In this case, 6 for all of them. And those are going to be used for a scientific analysis, especially focusing on things that will be needed for exploring and settling the moon, analyzing the resources. So things like trying to find the water, trying to find hydrogen or various other, elements, mapping, that kind of thing. So that's Artemis 1. And that would be in November of 2021 if all goes well. Now the second mission, Artemis 2, would be in 2023. And that would be about a 10-day mission. It would involve the astronauts. It just involves the rocket, the SLS, and the Orion capsule. What they would do is they go up into Earth orbit, then they orbit a couple of times around the Earth, and then they have their lunar injection, meaning they point the rocket toward the moon, and they do loop around the moon, but they don't land. They just go around it, and they calculate the orbit so it'll just come right back into Earth orbit. And of course, there would be more of these secondary payloads, as happened in Artemis 1, or will happen, but they're not determined yet. And then finally, Artemis 3, the last part of phase 1, that will involve the lander, HLS, the Human Landing System. That would be in 2024 if everything goes right. And the idea here is the astronauts will fly to a lander, which is already positioned then up in space by a commercial launch provider. They would land, stay about a week, and then return. So, and they would come back with samples and so on. So that will take care of phase 1. Now, in parallel, though, and it's easy to forget these things, but the robotic probes are really pretty important because they're the ones that tell you what are the best places to land, where are the resources, and there's a lot of these things going on. Starting in 2021, we are going back to the moon in 2021. We're just not sending people first. This is under a program called CLPS, which stands for Commercial Lunar Payload Services. And they have budgeted about $2.6 billion through year 2028. And these are contracts with commercial service providers. Currently, there's 14 of them, and that list could easily grow. And in fact, we've heard presentations from people like Astrobotics that are actually doing this sort of thing. What are they? Well, sometimes they're rovers, which are going around and taking samples, doing drilling to get samples, scientific instruments of every kind. Again, typically surveying for resources. Where is the water? Where are the minerals? And so on. Trying to get a better understanding of what's there that we can use and where should we land? What are good places to land? Another purpose for the robotic probes are pre-positioning supplies for the astronauts. And there may or may not be some of that. So seems like most likely there would be. In general, they're expecting about 2 flights a year, and each one of those, of course, could launch, multiple landers, or at least have multiple things available on the landers. So that is really a significant part of the program, even though it probably often gets forgotten. Some other interesting things going on. There's the technology of how do you get there, but there's also issues of, well, what happens if somebody stakes a claim, either a country or a company, what goes on? Well, one thing NASA's decided to do, and this is a rather bold and interesting step, they have put out a proposal that they want to purchase some lunar soil or almost anything that gets picked up from a commercial company, and they want a delivery, and it'll be delivered on the moon. Basically, they want to be handed a container, which will be labeled NASA. It'll be put it on there. And get this done by 2024, paying a nominal fee of $15,000 to $25,000. The fee isn't really the purpose. The real point of this is kickstarting a market for extracting off-Earth resources, and more generally, establishing a precedent. What's missing is regulatory certainty. It's hard to get investment from any kind of private organization if they're not sure if they're going to own the results or be able to, to make any money to get things done. So if it's predictable, you could actually imagine going forward with mining, and then in this case, transferring ownership. And it's proving that you can mine in a sense that even if it's just scooping up some dirt, and then transferring ownership. That's actually a major step forward. And it is a major step forward because the regulatory environment is a little bit uncertain right now. And partially because there are several treaties involved. First of all, it does appear that it is consistent with the Outer Space Treaty, which was signed in 1967, and it was signed by 110 countries, including the space powers like the US, England, China, Russia. It does say that no country can own the land out in space anywhere, the moon, Mars, or wherever. But it doesn't prohibit you from extracting resources and then furthermore selling them. And that is different than the Moon Treaty, which was signed in 1979, which treated the moon as a global commons. And what that means is there'd be a huge bureaucracy to decide what happens if somebody wants to make some money there. It's probably worse than that because the bureaucracy would hold things up. But the other thing is that, then there would be arguments over, well, how do you share this with all of humanity? So, how much money does Tanzania get when SpaceX decides to do a little bit of mining on the moon and that kind of thing? Now, this was actually rejected by the US and also by the other major space powers, China, Russia, Japan, and most of the European countries. So it's kind of it doesn't really matter too much. There are a couple of notable exceptions, however, though. Actually, France and India did sign this treaty. They may come to regret that since France has been involved in space in a while and India has a very active space program. They may come to regret this, but what probably will happen is they'll just end up ignoring it, which is what happens to a lot of treaties. Now, NASA this year outlined what they're calling the Artemis Accords. They figure, well, okay, we need to fill in more of what actually happens. How is commerce going to work? How is exploration going to work? And so they've outlined a series of principles. And at a minimum, anybody who partners with the US in the Artemis program will have to follow this. And their key terms are peaceful exploration, transparency, meaning saying what you're going to do, interoperability, which is just a basic technical requirement that the equipment has to work together. So the airlocks fit into each other, that kind of thing. Emergency assistance. If there are several people on, say, the moon, and one of them gets into trouble, the others would do what they could to help out. There's a registration of space objects, basically just saying what's there, releasing scientific data publicly, saying that resource extraction is okay, just being blatantly honest about it, saying we can do this, and also space debris mitigation, cleaning things up. So it looks like those are probably going to go ahead. I haven't heard a lot of people complaining about the Artemis Accords so much. Whether it gets that much attention, I don't know, but it seems like a good idea. And then there's the other one. Everybody's forgotten about Venus. It's one of those things where the moon gets a lot of attention and then Mars gets a lot of attention, and everybody forgot about Venus until this last month. And the reason is that astronomers have discovered that there is a chemical there called phosphine up in the atmosphere about 30 miles up, where it's actually cool enough that you could imagine there being life. Right down on the surface, it's horrible, of course, but 30 miles up, it's in Earth temperature kind of ranges. Why is phosphine of interest? Well, it might be a product of life. It could be treated as a biosignature, meaning that on Earth, typically, if you're in an environment without oxygen, and you have some microbes that can live without oxygen, quite often you find phosphine at the same time. And so it's considered probably, it could be a biosignature. Now, what's interesting is that, well, who's interested in Venus? Well, strangely enough, Rocket Labs was already proposing going there. Now, Rocket Labs was a small New Zealand company. It's really translated into an American company at this point. They wanted to launch a private Venus mission in 2023. Now we're talking about putting a 60-pound payload in their atmosphere. Not huge, but nowadays 60 pounds can contain a lot of capabilities. They want to do it with a rocket very similar to their lunar orbiter. They're actually one of the contractors under the CLIPS program, I believe, to NASA. And for about $10 million, they're going to do lunar orbiter, and they think they could use the same equipment to go to Venus. So You know, we were probably a little surprised in one of our previous meetings where we talked about countries like the United Arab Emirates going to Mars. Well, here's a private company talking about going to Venus. Things have really changed. There's been a long-term player in Venus, actually, and that's Russia. Actually, the head of Roscosmos, which is the Russian space agency, the guy came out and said, Venus, that is a Russian planet. And he's not completely without basis, actually. The Russians are the only people that have ever landed anything on Venus and survived. They've had a lander last as long as 2 hours, which is nobody else has managed to achieve. But the conditions are so bad there. You know, 90 atmospheres is the pressure of their down on the surface, 750 degrees. What happens is all our normal equipment melts. Our normal semiconductor chips that we would use for the computer controls, they melt. And now, of course, I don't think the Russians seriously expect that they could just say Venus is a Russian planet, although, like I said, they probably have more reason to claim it than, say, Columbus did for, you know, claiming the New World for Spain. So, you know, who knows? But anyway, a lot of people are getting interested in Venus once again. Now, I would put a couple of caveats in there about not getting too excited yet about whether there's really life on Venus for several reasons. And one of them is that link between the microbes and phosphine, although it's been observed, nobody actually knows why. So there's some question whether it's really a valid biosignature. Phosphine does also exist on Jupiter and Saturn, and people haven't been claiming that that means necessarily there's life there either. The real problem is simply that the knowledge of the chemical reactions that might produce phosphine are, strangely enough, just never been investigated that much. So we just don't know that much. And you know, there could be some weird chemistry going on, and that might be all it is. One other caution flag, if you will, was that the way they detect this is through spectroscopy. And this is probably absorption spectroscopy, where you look at basically what gets absorbed by light passing through in the atmosphere in this case, and you see at certain frequencies you get absorption of energy based on either individual atoms or maybe the bonds between them. Only one spectral line of several that exist for phosphine has actually been found, so that they're still going to be looking. You can bet they're going to be looking very hard for the other ones. So it's not necessarily 100% that they've really even identified phosphine. But keep in mind, it's still a pretty nasty environment. The clouds are sulfuric acid. So even if you're 30 miles up and it's, you know, a nice toasty 0 degrees centigrade, you know, around freezing or something, you're still dealing with sulfuric acid. That's not to say that you couldn't have life there. I mean, we do have extremophiles in the earth that live in mild acidic environments, but nothing as severe as the sulfuric acid is there. Doesn't mean it couldn't happen, you know, it just means it's tough because it's just a horrible environment to be in. So the conclusion is it's a pretty interesting idea to go there and look. And people have proposed all kinds of things, like putting balloons up in the atmosphere and letting them just float around, take samples and so on. So there are a lot of proposals. There are also even proposals for landers, some of which are much more mechanical, so they're not quite so susceptible to the electronics failing. So they, for instance, they would have a wind turbine in effect directly driving the wheels of a rover. People have explored some kinds of semiconductor replacements for the electronics that operate at a much, much higher temperature. They wouldn't be based on silicon, they'd be based on something else. I forgot what it is. So anyway, there are people that are really looking into this sort of stuff. So the chances are pretty good that over time there will be, you know, some attention paid to Venus. So now we're up to that point of the meeting where we ask, you know, how many launches have there been? How active is space activity these days? And this means that it's time to think about taking a poll. And it looks like we have, okay, okay, people are starting to answer this, and I should have started playing the. Okay, well, it looks like people are getting much better at estimating this. I think they must be looking at the same sources I have. So it looks like a lot of people are guessing around 9. That was actually 8 is the answer. We have one winner, whoever you were, you hit it on the nose. One of those launches is, in fact, this particular one was a Chinese launch. I just wanted to highlight that one because we typically think of launches as being these big rockets blasting off from land. And in this case, it's actually a sea-launched thing. Let me close this off here. So that was actually a Chinese ship. So I'm not going to go through each one of these. Maybe just highlight a couple of things. First of all, most of them are Chinese this time. The U.S. actually scrubbed at least 3 missions on the East Coast this month. They've just had all kinds of problems one way or another. Some of it was weather related. Some of it was equipment related. Some of them were both, actually. A couple of things I'll point out, though. One of the Chinese rockets, what I point out is the Chinese are basically just doing everything. I mean, for instance, on one of their rockets on the September 21st, they equipped it with fins, the first stage with fins, because they wanted to guide the descent so it won't fall on the villages. These are being sent, these are the launches that are out there in the middle of the land. And in the past, sometimes they've worried about the people that might have rocket parts fall on them, and sometimes they haven't worried. And now they're worrying again. So they're guiding them at least. The second thing I was going to point out was that one of them was launched from a ship. Actually, another Earth observation satellite, a small one, solid fuel based on truck mounted. It's based on military technology. So these are the smaller launchers. But there's a similar kind of thing going on in the US, also a failure. Kodiak Island, Alaska is a site that a company called Astra is using, and they're using solid boosters, probably ultimately derived from the military as well. Okay, one last thing is that, again, often in these launch pictures, we show the, flames shooting out and things shaking the earth as they take off. We tend to forget that nowadays, an awful lot of satellites are really, really small. And there's another part of the launch, which is what happens when you get up there. And here's an example of actually a Soyuz craft, very much like one of the ones that we just had this last month. And this is it's actually a third stage of one of their rockets. It gets up there, but then to launch the satellites, you have a variety of things. For instance, I think these are some of the launchers. We saw some things very much like that when we toured the nanoracks. Basically, they're just spring-loaded. You think of launches as being a big deal with flames and so on, but when you get down to it, a lot of satellites these days, the actual launch after you're in space, getting it away from everything else, is just basically spring-loaded. You trip a solenoid to let the spring shoot the thing out, and out they go. This is an example. In this particular Russian example, this is just a generic diagram, but in the mission that happened during this last month, there were 19 of these satellites shot off, which is not that different than the number shown here. And, in various sizes, all the way from, shoe boxes to toaster ovens, that kind of a size. So that's just kind of a reminder. Okay, well, that brings us to the featured speaker, Richard Easton. He is a science and technology journalist. He's the author of a book called GPS Declassified, From Smart Bombs to Smartphones. And it really explores how we got into space by dual paths. That is, there's the military and secret side of it, and there's the scientific and public side of it. And he really provides a peek behind the scenes at the really pivotal events in GPS, which of course is satellite-based. I should comment that his book did receive quite a bit of notice, especially from the national security establishment. I'm not sure if it's been noticed enough by the rest of the world, and hopefully this meetings like this will help with that. But it got quite a bit of good press, from the people more on the military side of it. They were pretty impressed. And with that, I'll turn it over to Richard Easton.
Is the audio good?
Yes.
Can you hear me? Because naturally the neighbor's air conditioning kicked on right before I came on. So, but today is, of course, October 3rd, and October 4th is the 63rd anniversary of Sputnik 1. And Sputnik's part of the story. So in some ways, this is propitious. And you've already seen my book. Okay. It just examines the development of GPS. As Greg was just saying, there's the huge military secret area of space, which spending is about equal to that of NASA, and yet it's much less well known. And it talks about the development of GPS from its secret Cold War military roots to its emergence as the first worldwide utility. We look briefly at the history of navigation. And why did we write the book? When we published it in 2013, there were very technical books about GPS, but there wasn't a good one for the layperson. And we tried to address numerous misconceptions and myths, some of which continue to live on seemingly forever. And I'll have a quiz about one of the big myths. And we also wanted to raise awareness of the vast non-military reliance on GPS. 4 years ago, my co-author and I spoke at what was Air Force Space Command. And at that point, it's then Commander General John Hyten, who's now Vice Chairman of the Joint Chiefs of Staff. He introduced our main talk, and he was worried that his chain of command did not realize the critical nature of GPS for civilians. So he wanted to get that across. Major takeaways: space tracking led directly to space navigation. GPS, most important navigational advance since John Harrison invented the marine chronometer. Many of you will have read Davos Sobel's wonderful book, Longitude, and I've been to the UK several times and have gone to see his chronometers in Greenwich. GPS is a positioning, navigation, and timing system, PNT. It's now critical to commercial and daily civilian life, making GPS a vital public utility for users worldwide. And there was talk about the Carrington event. Another Carrington event today could damage GPS and other GNSS satellites. So it's important that we have backups for GPS. All right, so have a little quiz. True or false, and these will be answered throughout the talk. Number one is DARPA invented GPS. Annie Jacobson, in her book about DARPA, claims this was the case. Number two, Ronald Reagan declassified for GPS for civilian use after the Korean airliner was shot down in 1983. You will find all sorts of articles claiming this. Number three, global synchronized time was an unexpected consequence of GPS. GPS, I just said, is a PNT system. Timing is extremely important, but much less visible to the public. Number four, the US government alters GPS signals during terrorist alerts. When we spoke to the National Security Space Institute in 2016, the same trip where our main talk was introduced by General Hyten, I got a question from an airman saying, gee, don't we distort GPS signals over certain countries at certain times? So that's something a military person thought. And number five, the number of users today threatens to overwhelm GPS's capacity. All right, so GPS was a technology invented in US military labs, and you're all, if you're my age, remember Gulf War I, all the uses of GPS, Schwarzkopf's left hook. Contrary to common misconceptions, GPS development envisioned non-military uses from the very start. We have, I'll quote a 1974 document, which is on our website, gpsdeclassified.com, which talks about a signal in the clear for both civilian and military uses. GPS has spawned complementary competing systems, GLONASS, Galileo, Beidou, which GPS is so significant, everybody wants one. And it's become integral to commercial, scientific, and civilian activities. Its global impact is greater than most people realize, and it's become an unseen but critical component of modern infrastructure. And my father was one of the major people developing GPS. That's my co-author, Eric Fraser, to the left. I'm to the right. He worked at the Naval Research Lab from 1943 to 1980. The first launch, we just had discussions about failed launches. I don't think any of the failed launches were unexpected launches. He transferred in 1952 to the Rocket Sonde branch at the Naval Research Lab, which was working on the Viking program, sounding rockets. Not to be confused, NASA later reused the name for soft landings on Mars. But in June of '52, they were doing a test firing of Viking 8. And Martin, the major contractors, changed the way it was bolted down. And there was so much vibration from the rocket that it took off during what was supposed to be a test firing. And Dad said poor Milt Rosen looked like he wanted to die. So he conceived his timation system, time navigation, in 1964, received the 2004 National Medal of Technology from President Bush. It actually was awarded in 2006. And here we are when he was put in the Inventors Hall of Fame in 2010. So I talked briefly about Sputnik 1, shock of the century. My dad co-wrote the proposal in 1955 for Project Vanguard. Sputnik 1 is October 4th. Sputnik 2 with a dog on board, Leica, a month later. So the White House announces Vanguard Test Vehicle 3 is going to launch the first American satellite. Now, TV3 was the first test of all 3 stages live on Vanguard. The Vanguard people thought it had a small chance of reaching orbit, and of course it got the name Flopnik. You can see on the left, it got about 4 feet off the pad and blew up. The middle is a cartoon. President Eisenhower was in the hospital, and he's looking at a very unhappy Vanguard rocket. To the right is the satellite that was on top of TV3 when it blew up. They brought it to my dad, and he put it in his little wood box. It's just over 6 inches across, 3.5 pounds, so pretty easy to carry. He bought a seat for it on a commercial flight back to Washington. I told that story to Dava Sobel, who I just mentioned, author of Longitude, and she wondered what TSA would make of that today. But it sat in our house overnight and is now at the National Air and Space Museum. That's a picture I took. And you see in front of it a picture of my dad and Marty Votaw examining it in 2008 on the 50th anniversary of the more successful launch of TV4 or Vanguard 1. So you can see it's right next to the Sputnik key, and I used to occasionally go there and talk about it to unwary people. So the more successful Vanguard 1 launched on St. Patrick's Day, 1958. It's the oldest man-made object in space. And the picture on the right, there I am sitting right next to it. I'm wearing the red coat. That's Oxon Hill Road in the background. We've had a lot of discussion of people working at home. Well, my dad used to bring the satellite home and tinker with it on our dining room table. So we didn't have the internet in 1958, but you could tinker, making sure that it would work and bring it home for family pictures. That's my 3 sisters and brother next to it. And here again is the TV3 we were just talking about, being examined at the Air and Space Museum in March 2008. There's my father standing up to the right, Marty Votaw just below him. You see Michael Neufeld at the top right, biographer of von Braun and a major space figure. The guy in white pointing at it is Chris Hagen, whose father headed up Project Vanguard. So they found it in pretty good shape. So how did we get to GPS? Ancient navigation used visual aids, used the compass. We talked about the longitude, the marine chronometer, and John Harrison. Navigating at sea, you could tell your latitude pretty well, but longitude, there were some notorious shipwrecks where they didn't know exactly what their longitude was. And then in the 19th century, the discovery of radio waves, et cetera, led to radio-based navigation. Many of you will know the story of Ernst Shackleton. He took his 6 best men and traveled on a small boat, the James Caird, from Elephant Island to South Georgia. And when they were getting close, his navigator, Frank Woolsey, told him he could not be sure of their position within 10 miles. They were trying to get sights in the rolling seas and the small ship. So when they found land in South Georgia, rather than try to sail around, they were on the uninhabited half, but they were worried that James Caird was in such bad shape that they might not make it. So Shackleton and 2 other men did the first climb over the uninhabited interior. And modern climbers using current technology have difficulty duplicating that feat. So all of you will know of Arthur C. Clarke, best known for 2001: A Space Odyssey. In a 1956 letter, he said, perhaps in 30 years, 3 stations in a 24-hour geosynchronous orbit will make possible a position-finding grid whereby anyone on Earth will be able to locate himself by means of a couple of dials on an instrument about the size of a watch. So he was maybe premature by about 10 years, but given that there were no human satellites up when he wrote this in 1956, it's a remarkable prediction. So I've talked about Sputnik, and many people track Sputnik. And they realized they could invert the process. Rather than using receivers on the ground to track satellites, they could use satellites to determine the position of receivers. And my father, in a 1967 slide presentation, said, to my knowledge, the idea of using passive ranging as a navigation technique was a result of a conversation between myself and Dr. Arnold Shostak of ONR in 1964. Some of you will know Arnold's son, Seth, is involved in SETI. At any rate, he was describing how the hydrogen maser worked. Hydrogen maser is a very accurate atomic clock and attained its fantastic timekeeping ability. At that time, I remarked that this device appeared to make passive ranging feasible. So passive ranging is how GPS works. If you know what time the radio wave left the satellite and what time you received it, you know you're on the surface of the sphere. The light travels 186,000 miles per second. So if it takes a tenth of a second, you're 18,600 miles from the satellite. If you know the satellite's position very accurately and have 4 satellites in sight, you can get your 3-dimensional position plus your time synchronization. That's how GPS works. That's what my father was testing in his timation system. So, Dad worked on the first satellite tracking system called Mini-Track. I mentioned Sputnik. On October 2nd, 1957, a memo went out that there'd be no more paid overtime for Project Vanguard. So my dad's colleague, Marty Votaw, said he went home tired on October 4th, and he got a call from my father. Dad said, the Soviets have launched Sputnik. And Marty said, that's good. It proves it can be done. And Dad said, no, you don't realize we've got to track it. Sputnik was transmitting at 20 and 40 megahertz, whereas the International Geophysical Year and Vanguard was going to transmit at 108 megahertz. So they had to convert Mini-Track to track it, and it took them 3 days of working without going home before they succeeded in doing that. So the space surveillance system, you see the red dot in the middle, the one on the left, that's Lake Kickapoo, about 130 miles from where I am. In 2013, I was living in a suburb of Chicago, and I was about to leave to pick up my wife at O'Hare when I saw a teaser for America's Most Secret Structures. It talked about what structure along 33 degrees north could be used for space war. And I thought, well, gee, space surveillance is 33 degrees north. So I set up my DVR to record it. And sure enough, it was about space surveillance. What it didn't indicate in the midst of its conspiracy theories was space surveillance was being shut down that week. So, at any rate, Dad realized that the Soviets would soon launch spy satellites, which would not be transmitting most of the time. So he worked on space surveillance, which would send a powerful signal, and it would reflect off the satellite to receiver stations. So it had 3 transmitter stations and 6 receiver stations along 33 degrees north, basically from San Diego to Georgia. And it could track satellites that were not transmitting. So here we talk about a number of pre-GPS space-based navigation proposals. Well, the first was from Edward Everett Hale in 1870. He wrote a short story called The Brick Moon. There are a couple based on Doppler. The first functional NavSat was by George Weifenbach and Bill Geyer of the Applied Physics Lab. When I was working on this book, I exchanged a couple emails with Bill Geyer. And then there's range measurement, which is what I was just talking about, how long the signals take to get to you. And again, the 2 major rivals were Timation and the Air Force's 621B. They were unified in 1973, and the 2 parties immediately began squabbling as to who did what. So, in 1968, the Joint Chiefs of Staff wanted a replacement for transit. Transit was 2-dimensional, occasionally available, about once an hour. They wanted something that airplanes could use. 3D, instantaneous, worldwide fixes within a specified accuracy. And just as we had the various armed services competing to launch the first satellite, competing over airplanes, the military wanted one system. So they set up a joint program office with the Air Force as the lead service. Brad Parkinson, one of my dad's major rivals for credit for GPS, led it from 73 to 78. In 1974, Dad talked about how precise orbiting clocks will prove to be a valuable tool in a variety of applications by providing the entire planet Earth with a single accurate time system, enveloping the globe in a web of synchronized satellite signals. So what they called in 1974, the time web. This is about 15 years before the World Wide Web. And again, the T part, he was envisioning synchronization. His Timation 2 satellite was used to synchronize time between the US Observatory in Washington and the Royal Observatory. So they were working on the time web even before the GPS program began. And again, time is very important in terms of fiber optic cables, in terms of Wall Street. We've even heard of people now wanting to make deliveries from grocery stores, putting their phones in trees right next to the grocery store, so they'll get the signal first. So time gets unusual applications. So Timation 3 launched in 1974. It put the first atomic clock, rubidiums, in space in 74. NTS-2, my dad's last Timation satellite, carried the first cesium atomic clock into orbit in 77. And NTS-2 plus the first 3 Block 1 test GPS satellites tested the GPS concept that with 4 satellites in sight, you could get your longitude, latitude, altitude, and time synchronization. Then they have the Block 1 satellites. Block 2 are the ones currently being used, and GPS 3, we were supposed to have the 4th launch of a GPS 3 satellite last night, and it aborted about 2 seconds before the scheduled launch. I don't think that's been rescheduled. Initially, they thought they could do it tonight, but I think that's been delayed. So again, GPS is the oldest, but everybody wants one. Most receivers, this is data from 2016. Most receivers today can use all 4, GPS, GLONASS, Galileo, and Beidou. And the Indians and the Japanese have regional system. GPS is a line of sight system. So if you're in Tokyo, you may have difficulty getting 4 satellites in sight. So they have satellites along the longitude of Japan to augment the other GNSS, Global Navigation Satellite Systems. And again, we're getting more and more receivers today that use all 4. And I talked about, we have on our website a number of documents. This 1974 one says the P signal is going to use for the precision military user, and the CA signal will serve as an aid in the acquisition of the P signal, and will also provide a navigation signal in the clear to both the military and civilian user. So all these articles, you can find them, recent articles that say that Reagan declassified GPS for civilian use after the shoot down of the Korean airliner. That's not true. It was always dual use. It was just that the Department of Defense had the deep pockets and the strong need for it. The civilian agencies said to the DoD, we'll be interested in it after it gets up running. And the micrometer V1000 was being sold in 1982. It was 160 pounds, used in pairs, $250,000 each. So at that point, you had 6 satellites overhead, so you just wait until those satellites went overhead. It's kind of like land stations using the 4 major moons of Jupiter to get their position. If you're at sea, Jupiter may be at the wrong side of the sun, so you can't see it, or it might be overcast. Whereas a ground position, they could just wait to get eclipses. Well, the same thing with surveying. Again, the first uses of GPS were by civilians. The Soviets shot down Korean airliner, And there was a statement that the US will make available to civilian aircraft GPS when it becomes operational in 1988. Well, that was premature. It was declared operational in 1995. So again, it was always going to be available to civilians, but they reiterated that it could be helpful to prevent another major navigation miss, resulting in the deaths of about 270 people. Congress, in its infinite wisdom, in the 1970s, when they were working on the shuttle, said all government satellites have to be on the shuttle. So the Block 2 operational satellites were scheduled to be on the shuttle, but of course Challenger blows up, and the Air Force had to develop the Delta II rocket to carry the satellites into orbit, and that delayed GPS's launch schedule by about 2 years. First major use, Gulf War. But the interesting thing about the Gulf War is that the military, the majority of receivers used were civilian ones. Military didn't, Gulf War, Saddam invades Kuwait, that was a surprise. And so the military didn't have enough military receivers. People's families sent them, troops got civilian receivers sent from their parents. And the government had just started degrading the civilian signal, selective availability. They had to turn that off since most of the receivers were, again, civilian receivers. Here I talk about almost 4,500 commercial versus 842 military. Very much surprised the Iraqis, who said we would get lost in the desert. So Schwarzkopf's last hook was facilitated by GPS. And a report from the year later said it was used more extensively than planned, and GPS should be considered for incorporation into all weapon systems. And 2012, there's a critical infrastructure dependence on GPS services, with the likelihood that threat actors are aware of that, and if they took down GPS or degraded it, it could have a significant effect on our economy. Or for that matter, a solar storm. So how do we become so reliant on it? A lot of it is selective availability being turned off in 2000, but also just the increasing miniaturization, your smartphone. So here you see how big initial receivers were. The TI 4100 is another example of a receiver that was available before Korean airliner was shot down. And again, it was used mainly for surveying. And then you just see the designated GPS receivers, Trimble, et cetera. And of course, now you can get it in your smartphone. So the old suction cups putting your Garmin on your windshield are largely a matter of the past. And it's basically used everywhere. Aviation, aerospace, railroads, tracking birds that migrate, monitoring people, precise timing, monitoring physical structures. So, if you're trying to see is the ground moving, trying to anticipate earthquakes, and also measure how significant they are. A survey from last year said 10 key industries have generated 1.4 trillion of benefit, 90% after 2010, and a GPS outage would impact us about $1 billion a day. So when we were working on the book, the best estimate we had was about 100 billion a year. Now this is about 365 billion a year. And if it occurred during critical planting season for farmers, it could go as high as 45 billion, obviously more than one day. And the advantage of a dual use is military status enhances the likelihood of sustained funding. A civilian system would require military protection. GPS is more secure than the internet. Again, in 2016, when we spoke in Colorado Springs, we got to see two SOPs where they actually control GPS. And you go into your general base security at Schriever Air Force Base, and then you have the enhanced degree of security to get to two SOPs, barbed wire. They have a backup system in Vandenberg in case something happens to Colorado Springs, but they are very much aware of the need to secure where they're controlling GPS. Scientific American last year, an article, GPS is easy to hack and the US has no backup system. If you look at the James Bond film from 1997, Tomorrow Never Dies, the Chinese are spoofing the GPS signal to a British ship. I forget if it's a ship, it might be a submarine, but GPS made it when it's a Bond theme. It's easy to spoof, jam. They found a problem at Newark Airport in 2010 with the GPS signal being jammed, and it turned out it was a trucker who was being tracked by his trucking company, a jamming device to subvert that. But we've had all sorts of things, GPS signal being jammed where Putin is in the Soviet Union, or not Soviet Union, Russia. There's a directive to build a backup in 2004, but it's been delayed. And I advocate they're building enhanced LORAN, much more powerful signal. GPS 3 will help with the problem. Signal is 3 times as powerful, much more difficult to jam. The problem is the military procurement is very slow. And just as in the first Gulf War, we went to war with primarily civilian receivers. The military procurement to have all of their receivers able to use all the advances of GPS, that's going to take a long time. And the ground system, OCX, has had a lot of problems too. So enhanced LORAN's been implemented in China, Russia, and Western Europe. Another solution which I've heard from DARPA is improved in inertial navigation. But I hope that we don't have a major problem before we have a good backup for GPS. And conclusions, it's an indispensable military asset. It's been called the first global utility, and we can't take it for granted. So again, DARPA did not invent GPS. DARPA helped fund transit, the predecessor system. Number 2 is false. GPS was always available for civilian use. 3, I've seen articles in GPS World that said global synchronized time was unexpected. PhD theses on Galileo. And as I showed you from the 1974 article, it was always envisioned. We don't alter GPS signals. And of course, by now, you've got 3 other worldwide systems. So we could do all we want and the receivers would convert over to the others. And GPS is not threatened. It's a passive system. So people talk about GPS tracking you. It doesn't track you. It's you may have apps on your phone, you may have your local phone service that tells where the phone is, but GPS itself, it just sends out the signals. There was talk in the late 60s about an active system, which would have helped with things like the Malaysian airliner disappearing. But an active system has the problem of saturation, that only a certain number of receivers can be used at a given time. Where again, GPS, it's basically an infinite number of receivers can use it. So I'll be happy to try to answer any questions.
So what was your biggest discovery as you were researching the book?
I would say my dad's major rival, Brad Parkinson. He's made claims like that my dad's system was two-dimensional. And I found his own 1974 document, which is on our website, which talks about timation being 3D. So just the contrast between what people claim today and what the original document said. Another major thing I found, there's been a huge controversy over Brad claims that he and 12 other Air Force aerospace people created GPS at the Lonely Halls meeting at the Pentagon over Labor Day 1973. And I found a September 21st document that contradicts that. So looking at original documents, the story is very different from what people claim today.
Richard, I have
Yes.
a few questions. When did NASA adopt GPS?
I think it would be probably early 90s for the shuttle. I mean, they had the 24 satellites up in 93. So it might have been more like mid 90s that they started using it for the shuttle, because they and one interesting thing they said in 1968, when Apollo 8 was going to the moon, they were tracking it from different ground stations, and they found that the positions of a couple ground stations were off by a couple hundred feet. So pre-GPS, they were realizing, again, when they're trying to track the first man-made mission to orbit the moon, that their tracking stations were giving different answers because of errors in the position. But I think for NASA, for the shuttle at least, it probably was the mid-90s.
Yeah. Is NASA going to use GPS to establish the halo orbit for the gateway?
Well, the GPS satellites are at 12,000-mile orbits, so you could probably get a pretty good accuracy even at the moon. I don't know about their specific uses, their specific plans for the orbital gateway, but it would seem to me like you could use GPS for that.
Yeah, they're going to use the NRO halo orbit, the near rectilinear orbit.
Yeah, like I said, they're the major rival system to my father's. My father's was mid-Earth orbit, either 8 or 12-hour orbits. GPS uses 12. The major rival was 621B, which was going to use regional constellations, one satellite in geosynchronous 24-hour orbits, and 3 or 4 satellites in high inclined orbits, which during the Cold War, the European constellation would have been denounced by the Soviets as a spy constellation, and it could have been knocked out by a single atomic bomb in orbit, whereas at 12-hour orbits, the satellites are never that close to each other. Another problem with 621b is with a regional constellation, you had to have the ground station in the same area, whereas originally for GPS, they were going to have the ground stations in either continental US or secure US territories, which led to the Indian Ocean gap. After the Cold War ended, they put a station in Diego Garcia. But the advantage, again, of having mid-Earth orbits is if you knock out or jam one ground station, the satellite can just go on to the next one to get its update for its clocks. So the timation in GPS mid-Earth orbit was much more robust during the Cold War.
Thank you.
In the story about the mission that was just scrubbed to put up the newest GPS satellites, they said that the new ones would be less resistant to interference. Are they just transmitting a stronger signal, or are they implementing some of the other kind of things you were talking about?
They will be more resistant. They're strong, like you said, stronger signal. I think there'll be additional anti-spoofing mechanisms, more frequencies, which help you with the distortion from the ionosphere. But I think a combination of more powerful, and I think they also have some additional anti-spoofing. One story, one of my dad's colleagues told me that he was in a meeting with the Air Force and NSA, and the Air Force was touting how good the encrypted military signal was for GPS, and the folks from NSA said, "Oh, we break those type of signals online." So
Thank you.
Could you talk a little bit about, the time whenever the civilian signal was actually had some intentional error in it, and how long that period lasted, and what how that limited our ability to use GPS during that time period?
all right, so the selective availability was the deliberate distortion of the civilian signal. As I said, it was put on, I think, in May of 1990 with Saddam's invasion of Kuwait. They took it off and they put it back on in 91. And it was removed in 2000. Remember, my father retired to New Hampshire and he got interested in restoring covered bridges. And he had his handheld Garmin and he was cursing selective availability. He was getting positions of various covered bridges in Vermont and New Hampshire, and he was cursing it. But like all good government programs, the DoD is degrading it, and the Department of Transportation, they would use land beacons where they knew they were, and they would tell you how much the distortion was. So if you're trying to land at an airport, the land beacon would, so you have one government agency, the DoD distorting it, and the DOT telling you how to get around it. And by the time they removed it in 2000, it was becoming a dead letter. But Nate is right, it did retard the use of GPS for civilian uses. And it also, the Europeans were unhappy about it. There was a proposal in the late 90s, they wanted to put some money in return for having some say in GPS. And President Clinton said, no, it's going to remain an American system. So they started working on Galileo. And by the same token, the Chinese initially were invested in Galileo, and then they had a dispute with the Europeans and they went off on their own. So GPS between 1991 and 2000, selective availability definitely retarded civilian uses of it. And I know one Air Force historian said, the Air Force didn't really understand how vast the civilian uses were going to be. Well, nobody really could. I mean, the runaway success was by no means certain. And circa 1981, when they decided to put on nuclear detection devices on GPS satellites, they realized that was an ideal use for it. That second constituency may have saved the program. So I know there were a couple of years where the Air Force zeroed it out and Congress put back in the money. Now that might have been just a smart move by the Air Force. They'll put it back in, so we'll get more funding. But there definitely was a constant struggle in the early 80s. GPS might not have survived. Some system would have eventually come out just because it was such an obvious use. But, I talked about the $1.2 trillion, again, part of GPS is success is just the miniaturization. I mean, instead of buying a handheld Garmin, you get it essentially for free in your smartphone. So that's a deal that's hard to turn down.
Have you ever made any kind of estimate of the return to the economy that it has made from the commercial applications?
Well, inception to date, it's cost about 50 billion. I may be a little bit off on that, but I know OCX has gone way over budget. It's probably 6 or 7 billion, but it might be 60 billion to put it conservatively. And again, 365 billion, and that's just in civilian uses. I mean, military uses have been myriad. So you compare, about a 6-to-1 payoff every year on the inception to date cost of GPS. It's truly a government program that has paid for itself over and over again.
Richard, I have a kind of science fiction movie question. In the motion picture 2012, a shuttle was about to land, but it was off course by several hundred miles. So they landed on the Los Angeles freeway system. But nothing inside the Earth would actually throw off a space shuttle because the GPS system is passive, right?
Yes.
So that's purely science fiction, that scene.
Yes. I mean, again, you in theory, if you had a bad solar storm, I'm trying to remember, I think it was 2014, a storm, major storm was a couple days either ahead or behind the Earth, in its orbit. So some sort of Carrington event is going to occur eventually. And certainly the ability, they're talking about devising satellites that can be used for a number of different applications. And the smaller Rocket Lab, almost launch on command. If we had, currently we have about 6 or 7 deactivated satellites that with the current system, we can only control 32. And they generally are using 31, so they can swap a new one in or out. OCX will allow us to use more, but again, the minimum for GPS is 24. So if you have launch on demand and less expensive satellites, maybe without the nuclear detection, that would make the system more robust in that knocking a couple GPS satellites out, we could quickly replace them.
Okay. Again, thank you.
When people talk about accuracy, they usually think in terms of latitude and longitude. How accurate is it vertically? It seems like that's different. I can tell because in my car, I get a reading of elevation, and it's often off by 20 feet, depending on which day I happen to be looking at the same spot.
The elevation is about half as accurate as the latitude and longitude. And I know my dad used to think that higher inclination GPS are inclined 55 degrees north and south, that a higher inclination, say 65 degrees, would give you more accuracy near the poles. But in general, again, a lot of the problems that people associate with GPS are just problems with the mapping. Back before COVID, I was commuting every day from downtown Dallas to Irving, and I'd frequently see they were doing construction along the route, and it might take my mapping about a week to adjust to the new construction. I mean, I'd be off the road according to it simply because they played around with the exits. But again, altitude is generally about half as accurate as latitude and longitude. And I have the same thing. I mean, I'll drive off the road. I was giving a talk 3 years ago, and one of the people in the audience said that the European maps for the roads are much more accurate than American. So if you're driving over there, I'm a chess player, and one of my chess buddies said he rented a car in Germany, and this is before GPS devices in your smartphone were very common. And he said after a couple hours, he went back to the airport and got a GPS device just because the addresses in Germany were baffling him. And I think the same thing's true in Japan, that, you know, it's not sequential. It's when the house was built. So it might be, 61, 69, 63. So for something like that, GPS navigation is critical to get to the house that you want to.
Okay.
And one last thing, I'm kind of like Moby Dick and the Great White Whale. There are two documents I'm looking for. There's an September 4th, 1973 document that is very important, that I'd never seen. Like I said, the September 21st one that's on our website makes reference to it, and the September 21st one makes it very clear that the major decisions on GPS were after Lonely Halls, because they had 3 scenarios that were developed at all Lonely Halls that all look like 621B. Scenarios 4 and 4A, it said developed subsequent. They look a lot more like my dad's timation system and GPS, but it'd be nice to get the original. And I'd never been able to see the original JCS 1968 document that talked about the requirements for a successor to transit.
Maybe one last question for you about the ability to give a reading on a GPS receiver at different speeds. I've seen different cutouts of ability to read, like a GPS 45 Garmin that I had when I was flying a Cessna 172 would not update its position above 90 knots. It would turn on and it would show the initial position when it first booted up, but I'd have to slow the aircraft down to below 90 knots to have position tracking. The later GPS 90, which was an aviation portable GPS device, nicely worked it up to at least 500 knots.
Now, I know some of them, when if it's truly been turned off, they'll take a little time to configure with the satellites. and obviously the military use is, well, I'm sorry, the use in airplanes puts the most demand on it, and more satellites. I mean, again, we've had cases where a drone was lost over over Iran, and probably resulted in the Russians, Chinese, et cetera, accelerating drones. And the Iranians said they spoofed the GPS signal. On the other hand, it took them a while to find the drone. So if they spoofed the signal, you think they could have found it pretty quickly. So, I mean, things are improving all the time. What time period would your problem with the above 90 knots have been the case?
Yeah, it was probably 96 or so.
Okay, so the GPS, they got the 24 satellite into orbit in 93, and the Air Force declared it as fully operational in 95. So, and it probably was just similar to my talking about the first Gulf War. Would your receiver have been a military or civilian?
That was a civilian sailing version, and Garmin later acknowledged that they had disabled the ability in that receiver to operate at above that speed. So I think it had to do with deliberately restricting the operation. I think the same is true with GPS for like suborbital launches or launches, that there's specific limits that get imposed just on the class and price point of the receiver.
Well, or for that matter, the Tesla. I mean, the difference between the cheaper and the more expensive Tesla is oftentimes just the software. And when you had a hurricane coming in, Tesla disabled that, so your cheaper cars could have the features of the more expensive ones. Yeah, that's an interesting software. I would guess by now, that for airplanes, none of them would have that restriction. Of course, there's discussion of drones of making it so that they can't go into certain restricted airspace. But that's an interesting feature. Again, selective availability circa 1991, 92. If you're trying to find the position of covered bridges, it's irritating.
Yeah. Okay. Well, thanks.
Well, Richard, thank you so much for presenting today. I definitely learned a lot more about GPS. Well, I can't say I learned a lot more about GPS since I read your book, but it was nice to see the presentation form of the material. So.
And thanks to all of you for your attention.
John, you were mentioning you had an event you wanted to share out and talk about?
Yes, I'm co-chair of AIAA's Johnson Space Center's annual technical symposium 2020. I did send you the flyer. Do you have that? Could you post that?
Oh, yeah, I could share it out. I didn't know if you wanted to share it out and talk about it, but yeah.
Yeah, it's this is a free virtual event. It's Saturday, October 24th, 2020. And there's a schedule on the flyer. It begins about 8 a.m. And right now we have 5 speakers plus our keynote speakers. So it's about 30 minutes a session. That's about 3 hours, but we're looking for more. Abstracts. Now the deadline for the abstracts is we added 2 more weeks. So it's the deadline is Friday, October 16th to submit your abstracts. The topic list is on the left. And if you can go to the bottom, Nathan, of the flyer? Thank you. A little more. You can send it to me. I'm the co-chair at john.diorio@sbcglobal.net. And we have room for 32 speakers. We use Zoom. We have 4 speakers per session. We have 4 sessions per track, and we have 2 tracks. Right now we have 5 abstracts, and we're looking, well, it'd be nice to have up to 16. So it would be an all-day event from 8 a.m. to about 4 p.m. So again, I just encourage you, if you don't want to speak, that's fine. You can attend. It's free. It's a virtual meeting. And basically, we have 2 types of speeches. We have those for managers and those for technocrats. You know, so if you look at our topic list again, there's also the website. The website is AIAA Houston.org.
And I could put this on our space events so people can go there and see the details as well. So
Okay, that's good. I appreciate that, Nathan. So, you know, I asked 1 or 2 other members here on the list, and they were considering submitting an abstract. So that's a good thing. But we will have the director of the Johnson Space Center as our keynote speaker at 8:15. And generally he has a real good speech on where JSC is at. And, you know, much like Greg Stanley, but more in-depth information.
well, sounds good. Did anybody have any questions about this event? I'll put the link on our space events page on our website, and of course you could reach out to John if you have questions or like to participate. The other thing I wanted to mention about the space news, Greg, you had talked about those 2 missions to the moon next year, Astrobotic and let's see, Intuitive Machines, I believe. Astrobotics, I should point out, is doing a special promotion with DHL, where they will take a small item of yours and send it to the moon along with that mission. And I bought the smallest one, which was enough to hold a little micro SD card. So these recordings of our meetings are going to be on that micro SD card. So all of y'all should know that some future generation will find this meeting on the moon and hopefully can make sense out of it.
Yeah, and they'll say, what was PowerPoint anyway?
Yeah. See, Greg, I got a question for you on your Venus report. Did they mention that they measured the upper atmosphere is about 84 degrees Fahrenheit and the possibility of raining up there, raining water?
Well, what I had seen was they were talking about just the fact that there's a range anywhere from 0 to 100. I mean, it's really hot on the surface and of course cold out in space. So there was a range in that. It was about 30 miles up. I don't remember one way or the other if they were talking about rain or what that rain composition was. Yeah, maybe it's possible that there's more water vapor there. I mean, the general theory on Venus is that the oceans boiled off, but you would think a lot of that moisture would still be up there, or at least maybe it's all sulfuric acid at this point. I don't know.
Right. Yeah. Thank you.
Oh, one other thing I should mention, Greg, I was reading some commentary or some comments about NASA buying the lunar soil from somebody else. And there is some clarification that it doesn't have to be an American company. They will buy it from anybody. So maybe the precedent could be the Chinese selling something to the Americans would be kind of interesting.
They'll sell us dirt.
Okay,
Perfect.
So, well, on that subject, I actually reviewed the solicitation in pretty good detail for a group I'm working with that would maybe be considering trying to do that. It's unfortunate that Bridenstine chose the word soil because the solicitation
Yeah.
specifically says combination of any of the following regolith types, rocks, or co-present species of ices. But it nowhere does it say soil. And it's actually something we should try to keep straight in our vocabulary, because if they were trying to provide samples of soil, there wouldn't be any. Soil is, by definition, a mixture with organic matter. And, that's something you could produce from regolith, and that would be a value-added product, but there isn't any there right now. Unfortunately, we have a lot of people, even in the technical community, that like to talk about lunar soil. And comes from things like the people that do civil engineering talking about soil mechanics, and some of the geologists on Earth. But like in The Martian, they were he was trying to make soil out of the Martian regolith.
Yeah, I saw the word soil in a lot of the things I was reading about that. I just picked that up too. But good point.
Yeah, but we ought to be helping try to keep the terminology straight.
Good point.
It drives the life sciences people kind of nuts.
So, David, just to make sure I'm clear on that issue, what's the correct way to refer to it again?
Regolith or dirt.
Regolith. Regolith. Oh, so dirt would also be okay.
Dirt's okay. Regolith is okay. Rocks okay. Ice okay. Soil not okay.
Sounds.
Question for David. Have you ever worked on a project maybe to try to solve for the problem of Venus, trying to cool it down or make it rain?
Oh no, we have had space settlement design competitions that have settlements that are in future history scenarios that we do with high school students, where I think there's one on the one on the Venus atmosphere, floating in the Venus atmosphere, and one on a high mountaintop, because on the high mountaintop you don't have anywhere near as much pressure, because designing a pressure vessel for a habitat on Venus is more like a submarine than a spacecraft, because you've got high pressure outside.
So what do you think the possibility of, let's say, designing a landing craft like that's built like a submarine, but maybe for a tall mountain? Would that be possible, or how easy would that be?
Well, I don't know that that would be easy, but I think that's certainly easier than one for the kind of the lower elevations. It's also like on Mars. You could do a space elevator to the top of a mountain on Mars, and we've done that scenario in the space settlement design competitions too. That there's almost no atmosphere at the top of the highest volcanoes on Mars.
And what's the percentage of pressure at the tallest point on Venus?
I don't recall that offhand. It was still a positive, I think a pretty strong positive pressure.
What did Greg say was the pressure on the surface? Greg?
It was 90 atmospheres is how it's been quoted. So that's pretty much like going pretty far underwater.
Yeah. Versus Earth is 15 atmospheres, right?
Yeah.
Well, the Earth is one atmosphere.
Oh, one atmosphere.
14.7 psi, but in terms of the atmospheres,
That's
it's
one atmosphere. That's right. That's
yeah,
what
so you're talking like 90 times that.
90 times. That's right.
One of the big challenges with Venus would be heat rejection from your electronics and all that when you're at such a hot temperature that's your heat sink. So it would probably take some different kind of materials than what we use right now for cooling systems like ammonia or Freon.
Well, even just having electronics work at all without melting, I think that was the.
The idea is you'd have them in some kind of an enclosure that's just got a maintained lower temperature, but it's like your air conditioner works in the house. You can keep it 65, 75 degrees in the house when it's 95 or 100 outside, but there's a limit to how much temperature difference you can get with those kind of materials. But we think there's other materials that might be able to be used that have phase changes that would be suitable for use on Venus.
Yeah, just a little bit of reading I had done there. It seemed like they were focusing more on simply finding really high temperature semiconductors where you can get the same kind of electronics, but with totally different material that can stand the heat in the first place.
Yeah, that would be another approach. I mean, we were looking at it for, if you were to try to have any kind of, more conventional electronics or anything there.
Yeah. Yeah, that seems like a losing proposition. It's just so hot there. The energy it would take.
Yeah.
I mean,
Sounds
look
like
at the size of our air conditioners here in Houston.
But, you think about some of the liquid metals and things like that, you might be able to have the appropriate phase change temperatures to provide the cooling you need.
What about tungsten and rhenium?
I don't know. I haven't really looked at it, that closely. It's more of a curiosity at this point than trying to go.
They're used.
Green design.
They have high melting points, and I think that they may be expensive to come by. Maybe they're found. If I read an article that they were found somewhere near volcanoes, but they're used for targets when people aim radiation, blowing off an anode to a cathode, so that they don't pit out. And so what I'm wondering is if the melting point would survive there. I don't know about the weight or what it could be combined with or anything.
Yeah, it'd be interesting to see. That might work.
Well, it certainly would be a design challenge because you have the pressure, even on the top of a mountain or volcano on Venus, you have the pressure, you have the temperature, and then what do you want to do at that height? Or what can you do at that height?
It sounds like we might need to have a Venus-focused meeting at some point soon. Don't have anything planned for December, so maybe we should all choose a different aspect of Venus to research, and we could kind of share it.
The actual the scenario we do in the competition, which was all kind of a fictitious future history, of course, but it's in the 2090s, and it's after the discovery of a material on Mercury that is produced through the heat and cooling processes of the surface of Mercury. That's a material that enables being able to build the settlement on Venus. Purely hypothetical, speculative, but that's the way that particular scenario works. So Nathan, you might ask Anita if she'd be interested in talking about it.
Yeah, that'd be neat. Or maybe even some of the students that participated, they could come and talk about how they.
Yeah, we could maybe see about doing that.
Well, it was good to see all of you, and thank you again, Richard. Allison, I'll have a link to your book so people can buy it on Amazon. It's on Amazon, right?
Yes.
Excellent. And it's a really good book. I bought it from Richard directly, so he hooked me up. But there's lots of little neat stories in it too. So I think y'all would enjoy it. Well,
and John, I'm sorry, I do still owe you a phone call. I realize I'd forgotten about that. But
Oh, yeah. Okay, that's fine.
okay. Well, we'll go ahead and end it here, and I look forward to seeing you all at our next meeting in November.
Thanks, Nathan. It was another great meeting.
Thanks, Nathan.
Thank you, everyone.
And
Thank you.
Be safe.
okay.
Have a good week.
Bye.
Good night.
Yes.